Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today we're going to talk about working in the blind. And if you think for a moment during the intro, you might figure out that there's actually two meanings to it. So let's get on with that intro. Here we go. And welcome back. I know it's a very fast intro, but most of you are pretty quick thinkers. And maybe you came to the realization that working in the blind, the two meanings are the most common meaning, you cannot see what you're doing, so you're working in the blind. And the other meaning would be derived from you have no idea what you're doing. You're just as blind as if you can't see what you're doing. You literally don't know what's going to happen next. And to me, that's the same kind of deal, working in the blind. In fact, it leads me to a little side story. You know, I always like to wander off in these videos. I give you a little side story. People are always a little chagrined, most of them, to find out there's no drawings for this aircraft. And there's no drawings for most of the things that I build when I'm in this type of situation. There's a reason for that. And people are just, they wrinkle up their faces when I tell them the reason. And it's obvious that they don't connect with the reasoning because they've never done it before. They've never been in that situation. This is not a situation where you can draw it all up and assemble it and go fly it. Because many of the techniques that I'm using, materials that I'm using, techniques that I'm using, and how I'm applying those materials never been done before. If they have, I'm unaware of it. There's no data readily available to me that says, well, if you do this and this, it works fine. Or if you do that, it's going to be a disaster. And it's one of the reasons that I do all these videos, is to try to deploy this information that I learn as I go along. But what I've discovered, building my first wing, building this wing, is that a lot of times I cannot predict how that process is going to go and how the materials are going to behave. I spend a lot of time playing with the materials. I flex them, I bend them, I stretch them, I flip them around to try to figure out how they actually function so that I can visualize what that process is going to be like. And I spend many hours thinking, I'm going to do this, 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 and this, and then I'm going to do that, and then the parts will be assembled. And more often than I'd like to admit, I'll get in the middle of a process, and it's like, wow, this is just not working at all. I learned this lesson building my first wing. That was the same kind of process of trying a lot of new things and not really knowing how they're going to turn out. It reminds me of a thing that happened when I was building my first wing. I was right in the early stages of it, had the first RC model and so forth, and just beginning to get my brain wrapped around what I needed to do to create this aircraft. And I happened to be walking along with a woman I was dating at the time, fellow engineer, by the way, she looks at me and she goes, I'm talking about building the wing and what I'm going to do and all that. And she looks at me and she says, you have no idea what you're doing. You're just making this up as you go along. And I thought, well, that sounds a little harsh. And I had to think about it for a second. I says, that's what engineering is, making stuff up as you go along. And I go, I'm just being an engineer. I'm designing as I go, and I'm creating processes as I go. So I have to admit that, yes, I have no idea what I'm doing until I've actually done it and see that it works. And that happens over and over and over again. When you try to develop something new like this. It's not stuff you learn in school. It's not stuff you learn from somebody down the street, unless they built the exact same kind of aircraft. You're on your own. And that's also why I've had comments like, why are you doing all of these subscale tests and why are you playing with these parts over here, and get on with building the aircraft, will you? And I was like, yeah, but I don't know how to do it. I have to build a test section for the wing. I have to see how the parts are actually going to go together. What steps do I follow? Do I do this first or do the other thing first? It's an unknown. And that's where subscale or partial assemblies also help. And to get to today's topic about working in the blind, that's what I've been doing lately to try to solve a problem of how do we bond the D-tubes to the spar? Now you see that I'm standing here next to the spar. You can barely see it here. There's a rib sticking up here. And you see, if I step out of the way, you'll see that I have it jigged up here. I have my dangleometer down there telling me how that rib's aligned. And I have a wire here stretched very tight across the top so I can line up all of the cord lines on the leading edge. The tip is done the same way. The two ribs are set with the appropriate washout, tight wire down there, and then I can line up all the other ribs in between. And I'm getting ready to install the leading edge tube here. And there'll be a couple holes in these ribs, and this tube gets bonded to these two ribs, and there's another rib that goes in between here. And this tube gets firmly, securely bonded to the inside of the D-tube when the D-tube is installed, and that allows this tube picks up the torsional loads from the D-tube and transfers it into the center section via this titanium fitting on the end. This slips into a socket on the center section of the wing, so when the wing tries to twist like this, it'll transfer those loads into the center section and consequently pick up my weight, which is dangling below the aircraft. So as I have this jigged up and getting ready to install here, I ran into a dilemma. I know from building the test section of this wing that installing the ribs and the process to do that is challenging and a little problematic. In fact, I've provided a link in the description to the assembly of that test section of the wing. You'll see how I actually did it. And one of the problems is that the ribs are really skinny. Here's one of the ribs. This is R16, goes out near the tip. This thing's only 1/16 of an inch thick. Two faces of carbon fiber twill over some very thin, super expensive honeycomb core. Really strong, really light, but really skinny. Way strong, probably stronger than I need. But I can't go any thinner on this or I'll have buckling problems. But there's another problem. Where do you put the glue? If I need to bond this inside the D-tube, how do you put a 1/16 of an inch bead on here? Okay? And have that stay nicely in place while you slide the D-tube on. Now I solved this problem on the test section of the wing. Go watch that video. You'll see that I actually inserted the ribs into the D-tube first and then bonded them in. Put a fillet of glue and structural filler around the edges on both sides and bonded the rib in. So the rib is bonded inside the D-tube, and I took the whole D-tube section and slid it onto the spar. It was a little problematic, but I was able to get it to work. And I had flanges on the base of the rib here, and those flanges would come down and bond to the spar like that. But all of it was done in the blind. The ribs are mounted, and adhesive is applied to all of the bonding surfaces, and then I drop it in place and clamp it. And how the joints actually end up inside the flanges, are they tight to the spar? Well, I don't really know for sure. Are my measurements accurate? Is it really touching? I hope so. And that's the problem of the other version of working in the blind. I literally, when this D-tube back here, when this D-tube gets put over the top of this, you can't see how any of the bonds turn out. And that's not uncommon in composite aircraft. I'll put down another link below that shows them putting together a standard fiberglass sailplane. And if you go far enough in the video, and I'll give you a time shot on that in the description, you'll see where they're bonding the upper wing surface to the lower wing surface in the molds, and the spar and all the other equipment inside the wing has already been bonded to the lower surface, and then they drop the upper surface in place. And that is all done blind. They'll have some inspection ports and they can look around and so forth, but you can't really see the whole bond. You don't know the quality of it until it's over. So what they do is they heap up thixotropic epoxy on the spar, and you'll see them do it. They make it this triangle shape. They put squeegee out a bag. They get a big piping bag. On goes the epoxy. Come down with a spreader, and they tent it like this, so that when the upper skin comes down, there's like a whole bunch of extra epoxy, and it just gets squished out, runs over the spars, smashes out against the inside surface of the wing, and they essentially ensure that they get a complete bond by overkill. It's just way more epoxy in there than you need to actually bond the two surfaces together. Because they don't want to be penny wise and pound foolish. You don't want to have the wing fail, so extra epoxy in there. Well, I can't really do anything like that because the weight is so critical on this aircraft. You could easily add a pound or two of epoxy and filler working that way with this wing. I have to work with some type of known accuracy going in. So I had this plan. Bond in the ribs first. I know that they're securely bonded to the D-tube, and then bond the D-tube to the spar with the ribs already in it. Peachy. And if these flanges are not bonded absolutely tight to the spar, it's probably okay. It's less critical because the D-tube's coming over the top of this rib. It's bonded to the spar. The D-tube is bonded to the rib. And if this rib is not bonded to the spar, well, there's the way the loads are carried, it's probably okay that it's not too securely bonded. I want to be very securely bonded between the D-tube and the rib because that's going to prevent local buckling, which is critical for this design. So that worked. I get down here to the main wing panels, which are at 18.5 feet long, and I happen to drop this rib in place. This rib right here, I put it in the D-tube, and I wanted to make sure I had clearance and so forth, so I went and set the D-tube on the spar, and lo and behold, I had just oodles of problems on my hands. What I hadn't planned on and what I didn't see coming, and there's just no way to know it, with this thin, very thin shell D-tube, this open edge back here, and I know you probably can't see it, you can see it up here, maybe right along here, that edge is not straight. Along the whole D-tube, there's a certain amount of waviness to it. It's not bad, it's not a bad part, and it's just some of the internal stresses that were in there when it was molded, but it's not dead straight because it's so thin. If it were thicker, had more skin thickness on it, it'd be dead nut straight, or at least it would match the mold. But that's not the case with this one. So what I have is a series of dips in that catch the spar and dips out. So in order to get this D-tube onto the spar, I got to spread it open like this. Well, if the ribs are bonded on the inside, I can't do that. It's bonded together. It's not going to open up enough to accommodate these warps in this edge to get it over the spar. So here I was, thought I had a process worked out on coming into the thing and discovered it no work. And that was yesterday. I was like, oh, shoot. I got a heck of a problem on my hands. I got to completely change this. I'm going to have to mount the ribs on the spar first like this, and then somehow drop the D-tube over and ensure that it gets securely bonded to the ribs when I do that, working in the blind. Now, if I had made drawings a year ago, 2 years ago, and said, here's how this aircraft is built, here's how the parts go together, that whole drawing and plans would be out the window. Drawing would probably be correct. Parts are the same size and shape, but the process is completely different. And I have to invent it on the fly. So I would have had to go back and change all of those drawings and instructions to indicate different process. And those are called revs, drawing revs. And in the aerospace industry, very common. You have a bunch of draftspeople, designers over here. You got other preliminary designers over here. And these guys go, and then you got the guys out in the shop. And then somebody says, hey, it don't work. And you go back to the designer, he works out something new, and then they draw it up, and they take that drawing out to the shop, and they, here, try this. And then maybe it works, maybe it doesn't. It's hard to know ahead of time. Now, if you're building something that you've built before using standard methodology, then it works. And if you have a company where you have multiple people to work different types of tasks, that works too. But it's one guy in his shop, it's highly inefficient. I'd spend so much of my time redoing drawings, it would just be a waste. So that's why I have the little joke about the drawings are much more accurate if I make them after I build the aircraft, because then I can just make the drawings to be as built. So for those of you who are always chagrined about where are the drawings, that explains why there's no drawings. So here we are back at this problem of how do I slip the D-tube over this thing and make sure that the ribs, these skinny little ribs, get securely bonded. Now, be honest with you, that's the first way I tried it with some test sections that I was building, just to see how the process would go. I had the ribs bonded to the spar, brought the D-tube over the top. And here's what I discovered. Because these are all at an angle, probably even the same problem if they're upright. The D-tube position span-wise is not readily known. There's a little bit of variance on that. And by a little bit of variance, I mean 1/4 inch, 1/2 inch, way more than a 1/16 of an inch thick rib. So what happens is, even if this is an 1/8 of an inch thick rib and you got a bead of epoxy on here, as you lower down the D-tube, you have to shift it sideways. And it peels all of the epoxy right off the rib, and it doesn't get bonded sufficiently. So that's a problem. How do you drop it on exactly accurately to keep that epoxy right on the rib? Well, I don't know precisely how to do that. I think my way through that. So I went through some thoughts. I thought, you know, I can come in, I can put flanges on this rib. I could take a thin layer, just one layer of carbon fiber, and I could bond this to the rib just like this, right? And I can create a T-shape. I don't know if you can accurately see that. Just get a little T-shape. And then I can coat this with epoxy up here. It's really wide, so any variances that I have is okay, and I can tent up some epoxy here, and the whole thing will just ooze on there, and I'm good to go. I'm like, oh, that's pretty easy because I can bond these little caps on here before the ribs are installed. And I keep a supply of this stuff laying around. I keep sheets of single layer carbon fiber laying around. I can just strip them, glue them on there. Well, there's another problem with that. This whole thing's tapered. It's tapered both in its chord length and its thickness. And the ribs are tilted. So that means this T that goes on here doesn't go on square. It goes at some angle. And the angle back here towards the trailing edge is almost 0. And up here at the leading edge, it's like 20 degrees to accommodate the sweep that's in the wing. Well, how do I put this on here? How do I glue this on here so that it's tilted 20 degrees up here and goes down to 0 at the back? They're like, oh, that's hard. I could never do that accurately. No home builder in his right mind would love me if I passed on something like that on the plans going, and now glue these on here with this weirdo angle. And by the way, the angle changes as you go back, so be careful. They'd hate that. So that's out. That's just not an option. Out. So then, here's our 13. I thought, oh, got it. I will make flanges right on the rib. You can see them here. Some nice 1/2 inch wide flanges on the rib. And they wrap around onto the top of the rib, so they attach to the face sheet so that the loads get transferred properly. And I can come on the inside and put a bead of epoxy on the inside, so I let me hold it up here. I can put a bead of epoxy on the inside, so I transfer the loads to the other side of the skin. And the best part is they're flexible. Nice and flexible. So when this gets crammed in the tapered D-tube, it'll match that slope. And I can cut little slots here at the leading edge, clip, 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 so that little flanges can go in like this and match the sweep angle and the taper. And it's like, smart, Ralph, good thinking. So easy to make the flanges. Grab some foam core, some 1/2 inch thick foam core, lay the rib on it, cut the foam core out, cover it in packing tape so nothing sticks to it, and you'll lay your rib on top of it, and you'll mold these flanges on there. And look at that, isn't that nice? And this didn't add much weight at all, and I got nice 1/2 inch wide flanges now. Mold comes out easy. I got 1/2 inch wide flanges now to put my epoxy on. Oh, new problem. Analogous to the problem on the D-tube trailing edge. Thin materials do not like to stay straight. And even though this line on here is continuous and straight, oh, well, the flanges that came off there are really wavy. They're like this. Got all these waves in them. Internal stresses that were in there. Pull it off the mold and you got wiggles in those flanges. So that, in order to accommodate the waviness in these flanges, I'd have to heap up a lot of epoxy on here. Because it's not like the flanges are oversized and sticking up like this, and the D-tube's going to push them back down. Oh no, this matches exactly the inside of the D-tube. So where the flange dips down like this, I got to have a lot of epoxy there to make up for that gap that's going to be in there. And because I'm working blind, there's no way to get inside and push it up there and make sure that it fits tight to the D-tube. So despite the fact that this is quick and easy to do and doesn't add a lot of weight and looks pretty slick, it's a non-viable solution. And you know, when I thought this up, it never occurred to me that this flange would be wavy enough to be problematic and that I'm going to have to heap up a lot of epoxy on there. Just my mind didn't visualize that. So, interesting experiment, but with an unusable result. So that one goes in the pile of could have worked. So here's where I am right now. Here's a piece of D-tube that was bad, and I cut it off so I could run this little experiment. And this goes out at the wingtip. And if you look inside, you'll see that I've installed some styrofoam, square styrofoam pieces that bend quite easily. And these are just CA glued to the inside surface. And I have them on the upper and the lower. And the idea here is that I will pipe in epoxy and structural adhesive in this groove that's here. And in the groove that's up here, it'll be a thixotropic solution, won't drip, won't run. I won't completely fill the groove. It's like half full. And then we'll come in, and then, so here's my ribs sticking up. Here's my ribs sticking up, and we're going to come in with the D-tube, and we're going to slide it right over the ribs, and those foam pieces will be a guide to keep the ribs from going in or out on here. And the foam, hopefully, will hold the epoxy and filler in place such that it beads up here along the edge and squishes down underneath. What will happen is this will be a ooey gooey mess on the inside, as it'll be on the inside it'll be shoving all of that epoxy forward. Fortunately, the rib is tapered and it shouldn't be too bad initially, and the rib will literally embed itself in a small bed of epoxy. Is this better than heaping it up on those flanges? I don't know, but I feel a little bit better about this one because I know that the epoxy and filler will be tight to the D-tube, that'll be wetted out and in there securely, and I know that there's enough foam height here to ensure that the epoxy rolls up onto, the epoxy will roll up onto the surface of the rib on both sides, so I get both faces of the rib bonded to the D-tube, and the foam only needs to be there to hold the epoxy until we slide it all together. The foam's non-structural. Now I thought about this and I thought, geez, how much epoxy do I need? Very little. 10 thousandths of an inch, 20 thousandths. But if I used foam that was really thin, do I have a piece of it here? Yeah. If I used this foam that's only a 1/16 of an inch thick, and that's on the inside of the D-tube, well, there's a chance, because the D-tube's flexible, we're going to flex this D-tube open like this to get it over the ribs. And because this is so thin, what are the odds that the rib's going to jump off one side or the other? That it's just going to go crooked and go skewing off to the side like this. The thinner this foam is, the higher the probability of that happening, I think. So I'm testing two different thicknesses here. I have 1/8 inch thick on the upper surface, I have 1/4 inch thick on the lower surface, and we'll see if there's any problems. Of course, a bit of a cheat. I'm working with a piece that's like 2 inches long instead of 18.5 feet, but it's the best I have for now. So in the remaining video here, you're going to watch me insert this. You're going to watch me put the epoxy in there and then insert this, and I'm just going to tape it together like this, and we'll set it, and then after it's set, we'll come back and we'll take a look at it and see the quality that we got. And I'm going to weigh these parts, and then I'm going to weigh it when it's all done, and we'll find out how much epoxy was required in order to bond this rib in, and I'll know how many inches it is, and then I can multiply that number by all the ribs and find out how much weight I'm going to add to the aircraft using this methodology. So we're going to do the little flip over thing here, and then you'll see the start of the process of filling this with epoxy and shooting the rib in here and taping it in place. And then we'll take a little pause, and we'll come back probably late tonight and see how it came out. So here we go, on to the next part.
Like a bird on a tree, I'm just sitting here. I got time, it's clear to see. From up here, the world seems small. We can sit together. It's so beautiful, you and me. We meant to be in the great outdoors, forever free. Sometimes you need to go and take a step back to see the truth around you. From a distance you can tell. You and me were meant to be in the great outdoors.
Hey, we're back. The epoxy's cured up enough to play with this, and let's take a look at the results we got. As you saw in the previous part of the video, it's very easy to slide the rib in here and secure it. And we see here on this edge that as I was hoping, the epoxy has rolled up out of the joint nicely, the excess epoxy and filler, and it is well bonded to the side of the rib, to that face sheet, just like we want. We see some areas here that appear to be blank, where nothing rolled up, but if I look inside, I can see that there's epoxy down in here, and it doesn't look too bad. Now, on this side here, if I can get this right, we got a good effect in here, but this is pretty blank, and it's pretty blank back here, so I'm a little uncertain about these. And on the opposite side, a similar effect. Here where the foam was thinner, the epoxy rolled up nicely, and this is filled all the way back into here. This appears to be well bonded, and it's filled and well bonded up here. And you saw my little note in the previous video, epoxy for the nose of the rib. I'll have to go into the D-tube and put in spots of epoxy where each rib goes before we slide them in. Make sure that we got something to bond the nose in place. And right now, this one probably okay. This one here, let's see if we can see it, appears to be blank along its whole edge. I can peek in here and see this. It's very hard to show you, but there's epoxy up in here. So I think the telling tale would be to tear this apart and take a look at the bond. So just rip the foam out of here and take a closer look. So let's do that now. Okay, so I've ripped the foam out here so we can take a look at the actual adhesive itself. And here on this particular side, this was the thicker foam that was here. And it appears that we have a good application of epoxy along this bond. It's well attached to the side of the rib. We're a little light here on the back end, and that's probably because of how I did the piping. The way I started the piping and started filling, I started at this end and worked this way. It probably behooved me to, on each rib, start at the middle and work this way, and start here and work out this way to make sure that I get enough epoxy here at the end of the D-tube. And the upper surface is the same way. Here at the end, not enough epoxy was put in the groove between the two pieces of foam. So critical to make sure that I have that area filled. It's probably also because as the epoxy gets pushed forward, as the rib is pushed in, it pulls the epoxy forward and leaves that area a little too dry. The front end bonded nicely, really secure, And same thing on the other side. We got a good bond. We have a good bond to the skin here, and it has rolled up onto the face sheet of the rib as predicted, and it is well bonded there. And same thing on the lower surface here. Now, what I see here already is that the thicker foam, the 1/4 inch thick as opposed to the 1/8 inch thick, used more epoxy. This whole arrangement, I'm going to have to be very careful on how wide I have the foam apart for the rib, because that'll drive how much epoxy is used. And I should probably use the 1/8 inch thick instead of the 1/4 inch thick. And just because of the height of the foam, I'll have less tendency to squeeze more epoxy in there. It just won't hold it. In fact, you saw me in the video on the 1/8 inch, it went over the top of the foam at points, and I scraped it down with a tongue depressor, took the excess off. So I think I'll go with the 1/8 inch foam, fill it up full, scrape off any excess, and we know it'll come out just about right for filling it in. It's interesting to note that all of the epoxy that's in here holding this rib in place weighs 4/10 of an ounce, and that's way more than what's needed to bond these parts together. As a matter of fact, the rib itself, this entire rib weighs 6/10 of an ounce, and the epoxy weighs 4/10. And this is a real common problem with ultralight composite aircraft, is that the adhesive that you're using to glue the parts together can weigh as much as the part in some cases. That's why on human-powered aircraft, they quite often allocate the amount of adhesive ahead of time, weigh it out, and that's all you get for gluing those parts together. It keeps people from making nice fillets that don't really increase the strength of the joint. And it's an issue on my aircraft, although I'm not that ultralight, but I am light and down into the region where epoxy becomes a significant portion of the aircraft weight. So we have to watch out for how much of this that we use. As a matter of fact, I calculated for all of the ribs in one D tube, it could take upwards of 3/4 of a pound of epoxy just to glue the ribs into the D tube, which it's a lot. 3/4 of a pound out of 100 to do one side, 1.5 pounds for the whole aircraft. That's a significant amount of adhesive. So I'm going to be very careful with the foam strips. I'm going to keep them closer together, not too much wider than the rib itself. And I'm going to use the 1/8 inch tall ones to cut down on how much resin that I put into the groove. Now the other thing I took a look at is I cheated a little bit here, and I played with the peel strength. Now in terms of the D tube lifting up away from the rib, that would be a very unusual load direction method. As this whole thing bends up and down, it doesn't really get a big peel load on it. But peel load would be the first mode of failure. It's the lowest strength of the joint. So that's what I played with. And we see that this came off right away. It just popped away so easy, and I'll do some more. There goes the rest of the way. And we have the same thing on the lower surface. In fact, the joint's not as strong as the skin itself. And that's another problem. So what's going to have to, I did not prep this surface. I did not clean it. It is a peel ply surface, but it's been handled. It's probably got skin oil on it. And I will have to make sure that when we bond the D tubes that we go in and we put some cleaner in here. And the other thing I'm going to do is I'm going to take a little acid brush like this one, and I'll come in here with just straight epoxy, no filler, and brush it in here and wet out this surface. I think it's an issue with, because this epoxy is highly loaded with filler, it's not as wet. And you don't get the wet out effect from the epoxy as well. So brushing on just a very thin layer of plain adhesive and then coming in with the filled epoxy resin, it will create a much stronger bond here, and that'll take care of that component. So I think this is a workable solution for assembling the D tube. We'll all keep our fingers crossed, and we'll see how it goes. Of course, I'm going to put in the foam in the D tube now, and I'll get it all set up, and we'll do a bunch of dry fits to make sure that everything's okay before we bond it, and make sure that it can actually slide on. I can spread the D tube enough to get it over the spar, all that good stuff. And last but not least, this happened to be my first experience of using fumed silica as a filler. Some people call it Cabosil. Very happy with it. This is the little bit of epoxy that I piped out on the paper here, and there's no droop, no sag, no nothing. So you apply this to a part and it will stay there until you press the mating part into it. So I thought that's pretty cool, and I liked using it. And it's for what it is, it's fairly lightweight. It's somewhere between cotton flocks and microballoons, and it's a nice solution. So I recommend using that. And we'll get this little peel strength problem solved going forward, but I think we have a viable solution for now bonding the D-tube onto the nose ribs. So thanks for watching. I'm not going to move the camera so you can see my ugly face. I'll just say fly safe and bye for now.